Good morning children and welcome back to your chemistry class. Today I am starting with a new chapter, that is surface chemistry. So the branch of chemistry which deals with the study of the nature of the surfaces of the solids and also with the physical and chemical processes occurring on the solid surfaces, it is called as a surface chemistry, right? There are several phenomena which can be explained only on taking into account the properties of some of the solid surfaces. The phenomenon of corrosion, right? Large number of chemical reactions in the industries, they all occur at the surface of the solid catalyst, and therefore this study of the surface phenomenon, it is of great importance in the industries and even in day-to-day life. So now the term this solid surface, what does it refer to? It refers to the atoms that are present on the exterior or the topmost layer of the solid, right? So there are different ways of studying 2 or 3 of the topmost layers of the atoms in the solid surfaces. Now this phenomenon, right, it requires a ultra clean surface, right? And for that, what is important? The basic requirement for which is that very high vacuum of the order, say 10 to the power minus 8 to 10 to the power minus 9 Pascal has to be obtained on the surface, right? Then this surface is to be cleaned, the solid material has to be cleaned, and it must be then kept in the vacuum, otherwise it will get covered with oxygen or nitrogen which is present in the air. Clear? So this is what we have to study in this particular chapter. So now to begin further with this chapter, let us first understand certain terms which are very important that we are going to use. I have written it down over here and I shall also explain it to you. So let us come to the first head term, that is adsorption. As the word suggests, adsorption, it is the temporary or the permanent deposition of one substance over the surface of some other substance. So how do we define what is adsorption? It is the change of concentration at a surface brought about by the action of the residual surface forces. This is known as adsorption. So try to understand when I am going to explain you everything about adsorption. So as I said, the temporary or permanent deposition of one substance over the surface of some other substance, it is called as adsorption, right? You can take many examples like accumulation of the dirt and then accumulation of ammonia or bromine on the surface of activated charcoal, or even your hydrogen, deposition of hydrogen on the surface of palladium or platinum, right? These are some of the examples where what do we see? One substance, it gets deposited on the surface of the other substance, right? So we can say that the phenomenon of accumulation of a substance on the surface of other substance, that is also termed as adsorption. So adsorption, what is it? It is a surface phenomenon, and this is only and only due to the presence of some unbalanced forces on the surface of the solids, right? Or we can say in the liquids as well. In solid or in liquids, always on the surface there will be some unbalanced forces. See, inside there is a balanced force. It is balanced. This atom is balanced from all the sides, right? But at the surface it is only balanced half it is balanced, half it is unbalanced, right? So again I am repeating. So what did I explain you over here? That there are some unbalanced forces on the surface of the solid or in the liquid state, and the interior of the solids and liquids, the molecular forces, they are well balanced. But these forces are not completely balanced where, as I told you, on the surface. So on the basis of their unsaturation, right, at the surface, what will happen? They have to satisfy the unbalanced molecular forces by attaching themselves to the atoms or the molecules or ions of the other substances with which they come in contact, right? So usually some sort of physical or chemical bonding takes place between these particles and the other substance that comes in contact with this solid surface or the liquid surface, right? So as the particles, they accumulate on the surface, their concentration is more at the surface now than in the interior part of the solid and liquid. So this change of concentration, more concentration will be found on the surface rather than and the interior part of it. So this change of concentration at the surface is called as your adsorption or surface phenomenon. I hope this adsorption is clear to you. Now let us talk about what is adsorbate and what is absorbent, right? So the substance whose particles get deposited on the surface of the absorbent, right? They are termed as what? Adsorbate. I repeat, the substance whose particles they get deposited where? On the adsorbent. They are termed as adsorbate. And what is absorbent? The substances which invites the particles of some other substance to deposit on its surface, then they are termed as adsorbent, right? So I have already given you many examples. The best example that you can always remember, that hydrogen or the deposition of hydrogen on the surface of the metals like platinum and palladium, right? Or in other words, you can also remember the charcoal, right? Charcoal over here will act as an absorbent, and then ammonia, it acts as a adsorbate. Okay, now next we come to what is absorption. So I have written over here that when the absorbate penetrates inside the adsorbent, into the bulk of the adsorbent, and it gets distributed throughout the lattice it gets distributed of the absorbent, then the phenomenon will be termed as absorption. So when the adsorbent is brought with the absorbate, what will happen? The absorbate molecules, they will penetrate into the bulk of the adsorbent, right? And this phenomenon will then be termed as absorption, right? So some of the examples of absorption could be like water vapor, which can be absorbed by anhydrous calcium chloride, then absorption of iodine by starch, then even the ink that is absorbed by the blotting paper. So these are some of the examples of your absorption. Clear? So now what is the difference between adsorption and absorption? This is now very important to be understood. So adsorption, as we have understood, it is a surface phenomenon, and the absorbate gets deposited only where? On the surface of the absorbent. Clear? Whereas absorption, it is a bulk phenomenon where the absorbate, it penetrates into the absorbent and gets uniformly distributed over here. Then second point about adsorption is what? The concentration of the absorbate on the surface of the absorbent is different from that of the bulk of the absorbent. Whereas over here what you will see, the concentration of the observate will be same throughout the bulk in the adsorbent, right? Then for adsorption, the rate of adsorption is high in the beginning, and then it starts decreasing gradually, right? And it reaches an equilibrium. Whereas what do we know about absorption? it proceeds with a uniform rate. So these are some of the differences between absorption and adsorption. We next come to another term that is called as sorption. Now what have I written over here? Phenomenon in which both adsorption and absorption, it occurs simultaneously. That is called as sorption. So sometimes what happens, the adsorption is followed by absorption also. So the absorbate molecules, not only they accumulate on the surface of the absorbent, but they also penetrate into the absorbent, interior of the absorbent. So in this case, it is difficult to find how much of the substance has been absorbed and how much is adsorbed over here. Therefore, in order to describe such kind of phenomenons, it is termed as what? Sorption. Right. Next we come to desorption. My next term is desorption. The process of removing an adsorbed substance from the surface of the absorbent, it is called as desorption. I repeat, what did I say? It is a process of removing an adsorbed substance from the surface of the absorbent. That is called as desorption. Then we also have to talk about the positive adsorption and the negative adsorption. So as the terms they say, we can describe accordingly. What did I say? A positive adsorption. So when the concentration of the absorbate is more, okay, at the surface of the adsorbent as compared to that in the bulk of the absorbent, then it will be termed as positive adsorption. I repeat, what did I say? That when the concentration of the absorbate is more, when the concentration of the absorbate, it is more at the surface of the absorbent as compared to the bulk of the absorbent, then it is called as a positive adsorption. But on the other hand, when the concentration of the absorbate is less than the bulk of the absorbent, then it will be termed as a negative adsorption. Okay. Then we come to the last term, heat of adsorption, which is also called as enthalpy of adsorption. So over here, as you already know, that adsorption is an exothermic process, okay, and it only occurs when there is certain release of energy. So how can we define what is enthalpy of adsorption? The enthalpy change involved in the adsorption of 1 mole of absorbate on an absorbent surface, that is called as enthalpy of adsorption. Note it down. What did I say? What is enthalpy of adsorption? It is the enthalpy change involved in the adsorption of 1 mole of an adsorbate on an absorbent surface. It is called as enthalpy of adsorption. The types of adsorption. Okay, so there are 2 types of adsorption depending on the forces with which they hold the absorbate on the surface of the absorbent. They are of 2 types. What are they? They are called as physical adsorption, which is also termed as physisorption. Okay, and the second one is termed as chemical adsorption, also termed as chemisorption. So we are going to talk about physisorption and chemisorption. So first let's talk about physisorption. What do we know about them? First let us study about both of them separately, then we shall discuss about the difference between the 2 types. Okay, So in this physical adsorption, force of attraction between the adsorbent and the absorbate is quite weak van der Waal forces. So I should write over here, force of attraction between the absorbate and the absorbent is weak van der Waal forces. Okay, thus they have low heat of adsorption. They are easily liquefiable gases, okay, with high critical temperature. With high critical temperature, right? What else do we know? It is non-specific in nature. Non-specific in nature, right? Then they are reversible in nature. Reversible in nature. Then they always depend upon the nature of the gas. More easily liquefiable gases are absorbed readily over here, which I have already mentioned over here. Then another point that I told you, enthalpy of adsorption is quite low. How much? About 20 to 40 kilojoules per mole, right? Then it decreases with the increase in temperature. Decreases with increase in temperature. Okay, thus we can say that low temperature is favorable for adsorption. Then no activation energy is required here. No activation energy required here, and it also results in multi-molecular layers, okay, on the absorbent. Forms multi-molecular layers on the adsorbent surface under high pressure. Okay, so these were some of the important points about physisorption. Now let's talk about chemisorption, and from these points only we shall discuss the differences. So what is chemisorption? It is a chemical adsorption where what do we see? That absorbate is held to the absorbent by the strong chemical bonds. Here adsorbate is held to adsorbent by strong chemical bonds. Okay, so if they are held with strong chemical bonds, what do we understand about the enthalpy? Enthalpy of adsorption will be high over here. See, enthalpy of absorption is low for physisorption, but enthalpy of adsorption is high in case of chemisorption, right? Some more points. It has high, now this one has, it is non-specific in nature. Then chemisorption, it has high specific in nature. right? It is highly specific in nature. Then this is reversible, then chemisorption is irreversible, right? I'm comparing both of them. Then next one, physisorption. It depends on the nature of the gases, right? But more easily they are liqueable gases. They are absorbed readily. They also depend on the nature of gases, but gases which can react with the absorbent, they show chemosorption. Then what do we know about enthalpy? As I have already mentioned over here, it is high. Why is it high? Because they are held by the adsorbate and the absorbent, they are held by strong chemical bonds. Okay. The next point that we read over here, physiosorption decreases with increase in temperature. Over here in chemosorption, what do we understand? It increases with the increase of temperature. So higher the temperature, that will be favorable for the adsorption in the chemosorption. Thus, high activation energy is sometimes needed over here, and it results into unimolecular layer. Here it results into multimolecular layer. Here it results into unimolecular layer. So these were the two different types of adsorption and their properties, and they can be easily differentiated also. Next we come to factors that affect adsorption. Okay, but before I begin with the factors that affect absorption, I would like to say that both the types of adsorption, that is physisorption and chemisorption, they both increase with the increase in the surface area of the adsorbent. This is a common point between both the types of adsorption. Clear? Now we shall move to the factors affecting adsorption. The first factor should be the nature of adsorbent. Okay, always remember, greater are the strained forces on the surface, more it is the ease with which the adsorption takes place on the surface. Thus, the activated adsorbents, they always have high adsorbing power. Okay, the second important point is the surface area of the adsorbent. Surface area of the adsorbent also plays a very vital role over here. Greater the surface area, more is the adsorption. Okay, write it down somewhere. Greater the surface area, more is the adsorption. Next we talk about the nature of gas being adsorbed. So easily liqueable gases, like for example say NH3 or CO2 or SO2 or HCl or Cl2, so on, with the critical temperature, where critical temperature is high, they are adsorbed to a greater extent. Okay, then fourth factor is the pressure. So adsorption increases with the increase in pressure. Increases with increase in pressure, right? So the effect of pressure is always large when at low temperature. Always remember this. Effect of pressure will be large at low pressures. Okay, and finally we talk about temperature. What do we know about temperature? Adsorption, we already know, it is an exothermic process according to Le Chatelier's principle. So adsorption, it decreases with the increase in temperature. Decreases with increase in temperature. Okay, so adsorption always decreases with the increase in temperature. Always remember that if the gas molecules, they are attached to the surface of the solid through, say, van der Waals forces, so what will happen? The adsorption will decrease with the increase in temperature, right? Now in case the gas molecules, they form chemical bonds with the adsorbent, then the absorption first increases and then it decreases with the rise in temperature. So these were some of the factors of adsorption. I stop over here. Thank you.